Good evening, everyone. Good evening, everyone. So, so we had discussed about continental drift theory in the last class. So before that, we discussed about isostatic movements and eustatic movements. So what are isostatic movements? Balancing movements. Okay, balancing movements. Because the upper lithosphere is like floating columns of the Earth's crust, and it balances in order to maintain stability, uniformity of the the weight across all the levels. So that balancing movements are called as isostatic movements. Okay, so whenever there is a change from the surface in terms of erosion, deposition, or any kind of degradation, so that will result in corresponding balancing movements. So it's called as isostatic movements. Eustatic movements are change in the sea level, global change in the sea level, eustatic movements. So that is caused by the change in the water volume or expansion or contraction of sea level. Sorry, the oceanic basin expansion contraction से होता है. So after that we started with continental drift theory. Continental drift theory was proposed by Alfred Wegener in 1912. So he proposed the theory to explain the differences in climatic conditions of any place. So, so any place located in a particular latitude should not experience difference in climatic conditions over a period of time. तो constant होना ही चाहिए, but वो change था. So then he started to think in the direction what would have caused the change in the climatic condition. Then he comes to a theory called as continental drift theory. So he made few assumptions here. So first important assumption, 3-layered CL, Sima, knife. CL is continental crust, Sima is oceanic crust. So knife is the core. Continental crust is moving, floating very freely over the oceanic crust. So based on this, he gave the idea of movement of the entire continents. Okay, you have to be very careful while using this word continent. You should use the word continent. You should never use the word plate here. ठीक है? So तब plate का बात नहीं हुआ था. The word plate itself was coined much late. The continents were actually moving, and there was Pangaea, Pantalasa, then got separated into Angara land, Gondwana land, in between Tethys Sea. So gradually these parts got separated and moved in different directions. So that is what is continental drift theory. As suggested by him, the forces responsible are pole fleeing force and tidal force. Pole fleeing force caused by the force to adjust the center of gravity and center of buoyancy. So tidal force are caused by the gravitational pull of sun and moon. Okay? But these are totally insufficient to cause the movement. So we know about that. The evidences are very important. Evidences बताइए. First one, jigsaw fit of continents. Second, structural evidences, that is mountains and plateaus in different parts of the world. Then stratigraphic evidences. So the rock layers. Then fossil कौन सा? Mesosaurus and Glossopteris. ठीक है. Then glacial evidence कौन सा? Tillites. Then placer deposits of Africa. So these are the very important evidences using which he gives the theory of continental drift, so which proves the movement of continents as such. So criticism include the different forces being insufficient and the why the drifting happened from the Carboniferous period only, and the overall the movement of the continents being very smooth. You know, so all these are the important criticism, so which he could not explain at that point of time. That was continental drift theory. Any doubts about this? Can we consider? Yes. Can say so. All the ocean bottom topography can be considered here. Anything else? बाकी सब क्लियर है? Time period of north south rift. So that is not required as such. So overall it started, the east west rift started around 300 million years ago during Carboniferous period. So that time itself the gradual rifting had started, but north south rift developed, it should be around 150 million years ago. 150 के आसपास होना चाहिए. Gradually it got bigger. The rifting was there, है ना, rifting cracking तो हो गया था, but gradually it became bigger over a period of time. ठीक है, let's move on to the next, sea floor spreading theory. See, the most important part, which was we can say the limitation of continental drift theory, is that Alfred Wegener did not know about the existence of mid-oceanic ridges. So he did not know about mid-oceanic ridges at all. So mid-oceanic ridges, the most important कौन सा है? Mid-Atlantic ridge, वर्ल्ड मैप में दिखाया था, याद है? अटलांटिक ओशन के सेंटर में है. So there was a very limited idea about the oceanic floor, because whatever the continents which are there, that was easily accessible. However, the oceans were not easily accessible because it was too deep, too dark and too cold. Oceans were too deep. The depth of oceans goes up to 4 kilometers, 5 kilometers, 6 kilometers, sometimes 11 kilometers also at some parts. Which is the deepest part? Challenger Deep. कहाँ पर है? Mariana Trench? Near Pacific Ocean, in Pacific Ocean. So basically इसके बारे में हमें पता ही नहीं था. What exactly is the overall features of this ocean? तो हम तो सोचते ठीक है, almost ऐसे ही होना चाहिए, plain जैसे होना चाहिए, because we were not having any of the instruments to reach this part. We developed that gradually. Okay, particularly after the Second World War, during the Second World War, you can say so, through the development of sonar. You know sonar? So how it works? By sending sound waves and by analyzing the reflected sound waves. Okay, so we can see in which surface it is falling, कौन सी surface के ऊपर कैसे गिर रहे हैं, तो what is the overall shape, ये सब तो हमें पता गया था. So we developed that and we used that in Second World War. Second World War में submarines का बहुत ज़्यादा यूज़ हुआ था, याद है? ठीक है. So तब तो उनको ये भी पता चल गया था कि ऐसे बड़ा बड़ा सा mountains है oceanic floor में. Oceanic floor has very big mountains like this. There are some islands, there's some plateau land, okay, table land like this. So they had discovered during Second World War itself, but they did not tell anyone because this was strategic advantage. So they used to use this to fight underwater. उसके अंदर उसके बीच में छुपने के लिए है ना, they used to use this. So once the Second World War was over, then they told the scientific community ऐसे ऐसे है ocean के अंदर, ऐसे ऐसे है. So there they had observed mid-oceanic ridges, most important, most interesting features of the oceanic floor. Mid-oceanic ridges को थोड़ा सा explore किए थे ये लोग. So then we got to know many things about the mid-oceanic ridges. That changed many things actually. So mid-oceanic ridges are the structures on the oceanic floor which are slightly elevated like this. Okay, so thoda sa elevated structures. So we got to know that by analyzing the oceanic floor, if this is the oceanic floor, it is not totally uniform, and along the regions where they said mid-oceanic ridges, these are the portion where there are high mountain kind of structures. It was too surprising to find these kind of structures on the oceanic floor. So that was first thing. We discovered the mid-oceanic ridges. Then we realized that at the central part of the mid-oceanic ridges, there is a continuous eruption of magma. Magma is continuously coming out from the much more interior part of the earth. It continuously comes out, and that too in what manner? Not like a volcano. In volcano, the magma erupts out very violently. Violently bahar aata hai. यहाँ पर तो the magma was slowly and continuously it is coming out. It was continuously erupting out, slowly and continuously, without much disturbance, smooth eruption. Okay, we discovered that these mid-oceanic ridges are the regions where the magma is continuously coming out. Okay. Then we started to analyze these structures. We studied the rocks of these structures. When we studied the rocks of these structures, we got to know one interesting thing, that the rocks which are collected at different distances away from the mid-oceanic ridge, their age increases in this direction. The age of the rocks, that is age of the oceanic floor itself, increases as we move away from the mid-oceanic ridge. This is 1 million year old, this is 2 million year old, 3, 4, 5, like this. As you move away, the age of the rocks increases, not only in this side, even in this side also. This side भी ऐसे continuously increase होता है. The younger rocks are near to the mid-oceanic ridge and the older rocks are away from the mid-oceanic ridge. ठीक है. And if you compare the rock samples collected at equidistance, okay, from a mid-oceanic ridge, let's say यहाँ से 10 किलोमीटर, यहाँ से 10 किलोमीटर. At equidistance from a mid-oceanic ridge, you collect the rocks. These rocks, which are located on both the sides away from the mid-oceanic ridge, they are exactly similar. They're exactly similar in age, in chemical property, physical property, magnetic property, सब कुछ same है. So I told you no two rocks in the world will be of same. ऐसा exactly same तो नहीं होता है, but यहाँ पर है. This was totally puzzling again. ऐसे क्यों हो सकता है? Anywhere you collect at 100 kilometers, यहाँ से जो 100 किलोमीटर में होगा, यहाँ पे जो 100 किलोमीटर होगा, वो तो exactly same है. ठीक है? So this was also totally puzzling. ऐसे कैसे हो सकता है? What is the reason behind this? We did not know. And we also got to know that the thickness of the oceanic crust is very, very thin. Whereas the continental crust extends up to 50 kilometers, 60, 70, 80 तक जाएगा. Mountainous region में it is very deep, 90 तक जाएगा. Whereas oceanic crust is just 8 to 10 kilometers. And after that it is mantle. The thickness of the oceanic crust is, it's very thin. कि ये भी पता नहीं था, what is the reason behind this? And इससे भी ज़्यादा puzzling था, we found very old rocks on the continent. Continent के ऊपर तो बहुत पुराना rocks भी मिला है, as old as 4.2 billion years. ठीक है? But none of the oceanic rocks in any part of the ocean, none of the oceanic rocks were older than 150 million years. उससे पुराना rocks मिला ही नहीं. The entire oceanic crust is very young. ऐसे बहुत सारा puzzling observations हमने किया. So there was no explanation for this. At that point of time, the theory of seafloor spreading came, which explains all of this. It was proposed by Harry Hess. Harry Hess proposed the theory of seafloor spreading in 1961. That is nearly 50 years after the continental drift theory came. Right? So after that they made a discovery and he proposed a theory. जब ये theory आया था, it was not majorly about continental drift or something. फिर इसको हम बाद में use करते हैं. We'll use it later to explain the movement of continents through plate tectonics. ठीक है. First of all, what is this theory? Theory of seafloor spreading का मतलब क्या है? So according to the theory of seafloor spreading proposed by Harry Hess, mid-oceanic ridges are active parts of the Earth's surface where the magma from the interior comes out through the cracks present in the Earth's lithosphere. It is basically part of the lithosphere where there is a crack. यहाँ पर gap है. It allows the magma from the interior to rise through this gap and it continuously erupts out. The accumulation of magma has resulted in the elevation. ऐसे ऊपर इसलिए कि ये जो माउंटेन जैसे बन गया ना, it is due to the continuous accumulation of magma which is coming out through that. इसलिए ये बना है mid-oceanic ridge. Second, what happens to this magma? This magma which is continuously coming out, it gets attached to both the sides of the oceanic crust here. This is oceanic crust. This is oceanic crust. It gets attached to both the sides of the oceanic crust as a wedging. Okay, you know, wedging. The rising magma gets attached on both the sides and it will push it apart. That is what is wedging. This newly rising magma will cool down by attaching to both the sides of the oceanic crust and it will wedge it apart. It will push it apart. यहाँ पर magma आ गया, यहाँ पर attach हो गया, cool down हो गया. As it cools down, it becomes totally hard rocks. Now the next coming magma will rise through the gap and it will push the older rocks. इसके पहले जो बना था उसको push करेगा. जो यहाँ पर था फिर यहाँ पर आ गया. यहाँ पर था फिर यहाँ पर आ गया. फिर यहाँ पर जो आया था वो cool down हो गया. It formed new rocks. Then again the magma rises and again push this. This will come here. This will come here. फिर यहाँ पर जो नया बना था वो इस तरफ आ गया. Like this, over a long period of time, the new oceanic crust continuously gets created on both the sides of the mid-oceanic ridge due to the rising magma. The rising magma is actually creating a new oceanic crust itself. That is why the rocks are always of same age on equidistance. क्योंकि एक ही टाइम में मैग्मा एरप्ट हुआ था, दोनों साइड से अटैच हुआ था एंड बोथ गॉट सेपरेटेड लाइक टू जुड़वा भाई, है ना, तो बचपन में सेपरेट हो जाते हैं. So they are exactly similar, right? So it's because they are formed at the same time. The rocks originated at the same time from the same magma. That is why their characters are same. Their age is same. Their physical, chemical, magnetic properties, everything is same. However far they are, they get separated gradually. That is also the reason the age of the rocks increases away. क्योंकि नया रॉक्स तो यहां पर बन रहे, पुराना रॉक्स तो इस तरफ पुश होके होके दूर चले जा रहे. इट इज मूविंग अवे ग्रेजुअली. बिकॉज ऑफ दिस द सी फ्लोर विच इज गेटिंग क्रिएटेड हियर, यहां पर क्या हो रहा है, द सी फ्लोर इज गेटिंग क्रिएटेड एंड दैट इज स्प्रेडिंग अवे. इट इज कॉल्ड एज सी फ्लोर स्प्रेडिंग. सी फ्लोर स्प्रेडिंग. तो ऐसे कब तक हो सकता है? तो ऐसे तो फिर अर्थ बड़ा होते जाएगा. The entire sea floor starts to grow bigger, right? So there is a balancing mechanism. जैसे जैसे इस तरफ से पुश होते जाएगा ना पुराना वाला, सो ये दूसरी जगह से ऐसे मैंटल के अंदर चला जाता है. As the sea floor gets pushed, the earlier, the older rocks goes into the deeper parts of the mantle along the regions which we call it as ट्रेंच. यहां पर जैसे क्रैक्स है, दूसरी जगह में दूसरी टाइप का क्रैक्स होता है, यहां पर भी डिसकंटिन्यूटी है, वहां पर कहीं भी ऐसे डिसकंटिन्यूटी हो जाएगा तो वहां पर नीचे चला जाएगा एंड इट मेंटेन्स द बैलेंस. ठीक है. द रेट एट विच न्यू ओशनिक क्रस्ट इज गेटिंग क्रिएटेड, इन द सेम रेट द ओल्डर वंस गेट्स डिस्ट्रॉयड. That is why older ones always gets destroyed. ये astrosphere के नीचे जाके उसमें mix हो जाता है and it will never be found again. That is why we don't find any of the rocks which are older along the oceanic crust. पुराना तो सारा खत्म हो गया. So exactly कैसे होगा? All of this will be explained in the plate tectonics. How it is getting destroyed along the trenches. What is trench? What do you mean by subduction? We'll discuss in detail over there. अभी के लिए इतने याद रखो, यहां पर क्रिएशन होगा एट द सेम रेट वहां पर डिस्ट्रॉय हो जाएगा. दिस थियरी इज कॉल्ड एज सी फ्लोर स्प्रेडिंग थियरी एज प्रपोज्ड बाय हैरी हेस. मैग्मा बन जाएगा. यस. रुक जाए. प्लेट टेक्टोनिक्स में बात करते हैं. ठीक है. तो अभी के लिए रिड्जेस का ही देख लो. सो दिस व्हाट इज अ रिड्ज वेयर द मैग्मा फ्रॉम द इनर लेयर इज राइजिंग and is creating a new oceanic crust on both the sides, and this creation of new oceanic crust will push both the oceanic crust apart. It will push both the sides apart, causing the entire sea floor to spread away from the mid-oceanic ridge. This is what is called as sea floor spreading. Sea floor spreading theory. ठीक है. सबका आंसर मिल जाएगा. हमारा प्लेट टेक्टोनिक से सबका बदला लेंगे. तो अभी के लिए इतना ही रखो. सी फ्लोर इज नॉट कांस्टेंट, इट जस्ट स्प्रेड्स. हाउ एग्जैक्टली इट हैपन्स, ऑल ऑफ दिस विल सी इन द प्लेट टेक्टोनिक्स.
Core samples and sonar readings from around the mid-Atlantic ridge. Analyzing core samples and sonar readings from around the mid-Atlantic ridge, Hess made an astonishing discovery. Analyzing core samples and sonar readings from around the mid-Atlantic ridge, Hess made an astonishing discovery. a phenomenon almost beyond comprehension. The age of the Atlantic Ocean floor, he determined, was progressively older the further it moved away from the ridge. Harry Hess had discovered that the seafloor was spreading. He concluded that molten rock was being forced up from inside the Earth at the ridge, where it then formed into new crust on the ocean floor. Gradually, it was pushed away on either side as more molten rock continued pushing up from behind it. Hess called his great discovery seafloor spreading.
Harry Hess was in a position that he could bring it all together. Things were spreading apart and new Earth was being generated. But if you did this for long enough, the Earth should grow. And it doesn't.
The Earth doesn't get any bigger.
No. Harry appreciated the fact that if new Earth was being generated in one area, they have to be consumed or recycled in another area.
The process that recycles the crust of the spreading ocean floor back inside the Earth is called subduction.
Hi everyone, we're going to talk about the Earth's magnetic.
Okay, that was about seafloor spreading theory. Seafloor spreading theory, when it was proposed at that time, I told you. So it was just the idea of how the ridges are functioning. So how exactly ridges are functioning and what is the overall the activity which is over there. And using this we developed further advanced theory which will explain most of the movements which happen on the surface of Earth. That is what is plate tectonics. Okay, it will complete all the earlier theories. See, and it is not like this was the only theory which came. इसके continental drift theory के बाद में बहुत सारा theories आया था. So many theories came and they were trying to explain what caused the movement in many different manner. And until we got to know about the oceanic floor, what exactly are the ridges, what is the mechanism over there, we were not able to completely justify the movements. Once we got to know about the oceanic floor and about the mechanism of ridges, so that gave a push for us to finally get the overview of the entire mechanism. Everything is connected. The rising magma on one end creates oceanic crust, on another end it causes the destruction. It also causes the mountains to form, earthquakes to happen, volcanic eruptions to happen. Okay? Oceanic crust continuously gets created, continuously gets destroyed, but the continental crust remain the same. All this will be explained by plate tectonics. So plate tectonics is the summary of all this idea, we can say so. It summarizes all these idea and brings under one heading, that is plate tectonics. Even now that is the most widely accepted theory, even though we have few limitations in that too. Okay? So we'll discuss that today in detail. So first write this, seafloor spreading theory. Mapping of oceanic floor revealed the following information. Revealed the following information. First point, presence of mid-oceanic ridges along the sea floor. Presence of mid-oceanic ridges along the sea floor. Next point, the ridges are volcanically active. The ridges are volcanically active, resulting in continuous eruption of magma. Resulting in continuous eruption of magma. Next point, rocks on either side of the ridge are of same age with similar composition and magnetic properties. Similar composition and magnetic properties. Next point. Age of rocks along the oceanic floor. Decreases away from the ridge. Decreases away from the ridge. Next point. Rocks of oceanic crust are younger than the continental crust. Rocks of oceanic crust are younger than the continental crust. Next point. Oceanic crust is thinner than the continental crust. Next paragraph. Based on the above observations, Harry Hess in 1961 proposed the theory of sea floor spreading. According to it, the continuous magma eruption at the oceanic ridges causes the rupture of oceanic crust. Rupture of oceanic crust. Full stop. The new lava wedges onto the oceanic crust. New lava wedges onto the oceanic crust. Full stop. This pushes the oceanic crust on either side. This pushes the oceanic crust on either side. Therefore, the ocean floor spreads. Therefore, the ocean floor spreads. Stop. The spreading crust sinks down at the oceanic trenches. Sinks down at the oceanic trenches and gets consumed. That is what is seafloor spreading theory. Yes. Spreading is moving. Move तो हो रहा है ना. That is what is spreading. The seafloor continuously moves. It is not constant. यहाँ पर create होगा, यहाँ पर destroy होगा. But जैसे जैसे move भी होगा ना. That is what is spreading of seafloor. Accumulation तो बस यहाँ पर होगा, थोड़ा सा होगा बस. Not rapidly. It will not happen rapidly. The magma which comes out through the mid-oceanic ridge is very fluid in nature. More than increase, it flows out. Increase नहीं होगा, वो rapidly build up नहीं होगा. वो a long period of time यहाँ पर continuously accumulate होगे, थोड़ा थोड़ा accumulate होगे, फिर build up होगा. Many of the times ridges even reach the surface. Okay, many of the times ridges even come above the surface. One such point in the mid-Atlantic ridge is Iceland. Iceland is part of mid-Atlantic ridge. वो पानी से बाहर आ गया है. कहाँ पर है Iceland? This is Iceland. Greenland के बगल में. It is part of mid-Atlantic ridge only. ठीक है? So some of them are so tall. किसके नीचे? कॉन्टिनेंट. कॉन्टिनेंट के ऊपर है तो कॉन्टिनेंट ही होगा. So next one, plate tectonics theory. It is too slow to affect the sea level. It is too slow. So what is the rate of movement of this oceanic floor? What is the rate of movement of this oceanic floor? I told you oceanic floor is continuously moving, right? So what is the rate of movement? 6 to 15 centimeter per year. 6 to 15 centimeter per year. It is considered to be very, very slow to cause the rise or fall in the sea level. It will not cause rise or fall in the sea level. So next, plate tectonics theory. So this is very important part. ध्यान से सुनो. I will give you a proper dictation in a detailed manner. You don't have to worry here. So I told you continental drift के बाद में बहुत सारा theories आया था. Many theories came after the continental drift theory to explain the movement of continents. What caused the movement? So in 1961 comes seafloor spreading theory, which gives some idea how the oceanic floor is actually. So after that rapid changes happened, बहुत सारा theories आया था. So one final shape is given to all these ideas through plate tectonics theory. The word plate was coined by J.T. Wilson in 1965. The word plate is coined by J.T. Wilson in 1965. That is why you should not use the term plate in continental drift theory and seafloor spreading theory. दोनों में use नहीं करना है गलती से भी. ठीक है? So it is coined by J.T. Wilson and J.T. Wilson, not T.J. Wilson, because both are different. दोनों geographers ही है, दोनों geomorphologists ही है. Okay, so it is J.T. Wilson in 1965. ठीक है. The theory of plate tectonics is proposed by, okay, we attribute this to three persons. One is Morgan, who worked independently. Then comes Mackenzie and Parker. कि these two work together and the overall idea was almost similar and सारा मिल के हमने theory बनाया है, so that's why we attribute the theory to all the three person, तीनों को मिला के हम बोल देते इनका ही है. It was in 1967. कौन है? Morgan, Mackenzie and Parker. Okay, these were the persons who proposed the plate tectonics theory. What is the theory? According to the plate tectonics theory, the entire Earth's outermost layer, that is lithosphere. Okay, here we properly describe the outermost layer. The outermost layer is lithosphere. Lithosphere is a very hard and outermost layer and very hard and rigid layer. It is like a shell protecting the earth. Even though it is the lightest layer, okay, बहुत light है, but it is very hard and rigid layer. It protects the interior layers. Okay, like a egg. Okay, so कोई भी egg ले लो, अंडा, so उसका जो outer shell रहता है ना, उससे भी thin है actually. The overall thickness, overall radius of the earth goes up to 6,300 kilometers. The thickness of lithosphere is just 100 kilometers. So it is very, very thin. By comparison, it is much thinner than the outer shell of an egg. Right? So this outer hard shell is called as lithosphere. And lithosphere is above the asthenosphere. Okay, basically below the lithosphere, there is asthenosphere. Asthenosphere is semi-solid, semi-liquid state. Okay, जिसके बारे में हमने already पढ़ लिया है. It is in semi-solid, semi-liquid state. थोड़ा सा pressure दे दो, melt हो जाएगा. Okay, it undergoes melting very easily under pressure. Above this, there is a solid layer which we call it as the lithosphere. But however, this lithosphere is not a single outer layer. It is broken into different parts. It is broken into multiple different parts. Okay, so we imagined an egg. So abhi imagine karo boiled egg with the outer shell which is cracked. Cracked, but it is still intact. It's a cracked outer shell, but it is still intact. That is what is lithosphere. And each of this individual part of lithosphere is what we call it as plate. Each of the individual part of the lithosphere is called as plate. There are multiple different plates covering the entire earth. Some of them are very big sized, we call it as major plates. Some of them are small, we call it as minor plates. So what exactly is a plate? Okay, labeling is very important. आप लोग भी लिख सकते हो, एक्स्ट्रा मार्क चाहिए तो. So what exactly is each plate? You take each plate each plate is like a broken part of the lithosphere. On one end, it may contain continental crust. Another end, it may contain oceanic crust. So lithosphere, what is lithosphere basically? It is the crust plus uppermost part of upper mantle. That is what is lithosphere, which is attached with the crust and it acts as a single unit. This is the uppermost part of upper mantle, which is attached with both continental crust as well as oceanic crust. Continental crust is thick. This is oceanic crust. and below that there is upper part of upper mantle. Together it is one plate. A plate may not necessarily contain entire continental crust. No plate actually contains completely continental crust. Okay, it will contain both the continental crust on one end and oceanic crust on another end. Both are merged together as a single plate. So, but there is one plate which is made up of completely oceanic crust. That is Pacific plate. Okay, I'll show different plates. दिखा दूंगा. There is only one plate which is made up of only oceanic crust. यहाँ पर continental crust है ही नहीं है. There is only one such plate, that is Pacific plate. Rest all the plates, in one end there is continental crust, another end oceanic crust. Together it is one single plate. So below this we have asthenosphere. Which is in semi-solid, semi-liquid state. It is because of the asthenosphere it is because of asthenosphere, which is like a cushion on which the lithospheric plates sit. It is like a cushion on which the lithospheric plates sit, and the lithosphere is a very hard and rigid part. बहुत हार्ड रिजिड पार्ट है, इसके नीचे थोड़ा सा कुशन टाइप है, जिसके वजह से दिस लिथोस्फेरिक प्लेट्स आर इन कंटिन्यूअस मोशन. They are not completely static, they completely move, but they move as a single unit. This is what is one single unit. This is what is one single plate. It moves together in whatever the direction there is a force. There are various forces. Along with this, there are various forces acting from the Earth's interior. There is a large scale currents of magma which is trying to push it upwards, push it sidewards. Okay, इस साइड हो सकता है, इस साइड हो सकता है, कोई भी साइड हो सकता है, ऐसे कंटिन्यूअसली इसको पुश करता रहता है. There are various different forces acting from the interior and trying to push this. And उसके नीचे भी थोड़ा सा कुशन है, it easily moves over that. So that is what is plate. Each plate is capable of moving on the asthenosphere. So how exactly it is different from the continental drift theory? This is what is plate tectonics theory. Plate tectonics theory इतना ही है. So plate tectonics theory बोलता है कि the entire Earth's outer shell is lithosphere. It is broken into different plates. Each individual plate is capable of moving above the asthenosphere. It may contain continental crust, oceanic crust, but it moves as a single unit. But while it is in motion, it causes all the changes. जो भी changes होगा, जो भी creation, destruction जो भी होगा, ये movement के वजह से ही होगा. वो कैसे होगा बात करेंगे. How exactly it is different from the continental drift theory? The first continental drift theory assumed there is 3-layer structure, Cl, Sima, knife. Here we have lithosphere, asthenosphere. It is not Cl and Sima which is one above another. Cl and Sima is part of both a single plate. It is the plate which is actually moving, not just the Cl alone. It is the plate which is moving over asthenosphere. ठीक है? That is the basic difference. Second important difference is that Alfred Wegener assumed that when the continental crust moves over the oceanic crust, it causes no resistance at all. It moves very freely. वही major गलती था. These are the rocks which are very hard and rigid. When they are in motion, it offers a very high resistance. When they are in motion, it offers a very high resistance, and that causes deformation. That causes deformation along the edges. Sometimes it causes compression. The layer gets folded, resulting in the formation of fold mountains. Sometimes it pushes each other, resulting in the formation of trenches and subduction. Right? Sometimes when they move away, there is a gap in between, the magma comes up, creates a mid-oceanic ridge over there. The movement is not very smooth. The movement is not very smooth. It offers a very high resistance, and that causes all the changes. Whatever the changes which we see on the surface of Earth, the geomorphic processes due to the endogenetic, the mountain building, majorly the different types of mountains, all of these are the result of this kind of movement. The movement of plates. Plate movements. The movement of plates results in building up of certain different features. Okay, building up of mountains, building up of ridges, trenches. That is why it is called as plate tectonics. The building movements. Plate tectonics is the study of these building. Okay, the structures which is getting built. That is what is plate tectonics. It is the study of all these movements and the resultant of these movements. Okay, this is what is plate tectonics theory. Along each of these plates तो बहुत सारा है. There are 7 major plates and many minor plates, and all these plates are in continuous motion. They are not completely static as such. They are in continuous motion. This plate moves in this direction. मान लो this is moving in this direction, this is moving in this direction. ये इस तरफ जा रहा है, कि इस तरफ जा रहा है, ये भी इस तरफ जा रहा है, कि this one is going in this direction. Some of them collide with each other. Two different plates can move towards each other. Two different plates can आवाज नहीं आ रहा है? अभी आ रहा है? कम हो गया? अभी आ रहा है. So two different plates can move towards each other. Two different plates can move away from each other, or they can just slide past each other. है ना? So these are the different types of plate movements. Because of these different plate movements, we have different types of plate interactions, and that each of the interaction explain many of the things which we will discuss in very detailed manner. So what exactly happens in each of the interactions? Okay, so that we will discuss. That is also part of plate tectonics. But the overall theory is this: there is lithosphere. Each part of the lithosphere is a plate, and lithosphere is moving over the asthenosphere, because of which all the plates are in motion. And a plate contains continental crust, oceanic crust. Below that there is upper part of upper mantle. Together it is one plate, and each plate is moving continuously in all the different possible directions, and that causes the formation, which is we call it as the plate tectonics, the study of such formations. Atlas है? So खोलो atlas. रुक जाए सारा डाउट्स हो जाएगा. थियरी तो अभी शुरू हुआ है. ठीक है, इस क्लास में भी पूरा खत्म नहीं होगा, नेक्स्ट क्लास में पूरा खत्म होगा. ठीक है, इन द वर्ल्ड मैप में देर आर फ्यू थीमेटिक मैप्स. सो वन ऑफ द मैप विल शो द डिफरेंट प्लेट्स. दिस वन, ये वाला ओरिएंट ब्लैक स्वन में पेज नंबर 85. दिस वन, पेज नंबर 85 इन ओरिएंट ब्लैक स्वन. एटी 85 जो भी है देख लो, आगे पीछे हो सकता है. ओरिएंट ब्लैक स्वन से तो है 84 85 में होगा. ऑक्सफोर्ड वाले बताइए. 85. अच्छा ठीक है. ठीक है, ओवरऑल यू विल फाइंड दिस मैप. ठीक है, ये वाला मैप ढूंढो. So what we had seen in the world map is majorly continents and oceans, right? Continents and ocean. If you remove water, what we see is plates. पानी को हटा दो, आपको मिलेगा plates. So basically continents and oceans both are part of plates. Okay, we have a total of 7 major plates, that is big plates. 7 major plates. What are the 7 major plates? Identify करो. ये जो cracks दिखता है, boundaries दिखता है, these are the plate boundaries. Okay, this is the boundary of Pacific plate. This is number 1, Pacific plate. This is the largest plate and it is the only plate with completely oceanic crust. You can see there is no continental crust at all. But ऐसे जरूरी नहीं है कि continental crust होना ही नहीं है. So दोनों हो सकता है. A plate may contain both continental crust as well as oceanic crust. Second one, you can see this one. This is North American plate. North American plate. In one part there is continental crust, another part there is oceanic crust. यहाँ पर भी बीच में oceanic crust है, देखो. This is North American plate. Number 3, South American plate. We are seeing the major plates. On one side there is continental crust, another side there is oceanic crust. बीच में boundary नहीं है. It is part of the same plate. The individual unit is a plate. Continents and ocean वो हमारा E division है. Okay, it is just for बाहर का reference है. But actual geomorphic division is plate. On one end there is continental crust, another end there is oceanic crust. This is third. Number 4, African plate. अफ्रीकन प्लेट देखो, सेंटर में है कॉन्टिनेंटल क्रस्ट, सारा साइड्स है ओशनिक क्रस्ट. नंबर 5, यूरेशियन प्लेट. यूरोप एंड एशिया टुगेदर इट इज अ सिंगल प्लेट. इट इज कॉल्ड एज यूरेशियन प्लेट. Okay, this is the boundary of Eurasian plate. Number 6, Indo-Australian plate. इंडो ऑस्ट्रेलियन तो और अजीब है, देखो एक साइड में कॉन्टिनेंटल क्रस्ट है, इंडियन पार्ट, यहां पर कॉन्टिनेंटल क्रस्ट है, बाकी सारा ओशनिक क्रस्ट है. इंडो ऑस्ट्रेलियन प्लेट. वेयर इज द 7th प्लेट, मेजर प्लेट? अंटार्कटिका प्लेट. देखो अंटार्कटिका प्लेट. These are the 7 major plates. There are many minor plates. Some of the important minor plates. Between Pacific plate and South American plate, there is a plate called as Nazca plate. Nazca. साउथ अमेरिका और पैसिफिक प्लेट के बीच में नाज़का प्लेट. नाज़का प्लेट के ऊपर है कोकोस प्लेट, छोटा सा ये जो बीच में फंस गया, कोकोस प्लेट. यहां पर देखो, बिटवीन यूरेशियन एंड पैसिफिक प्लेट देयर इज फिलीपींस प्लेट. ओके, दिस इज फिलीपीन प्लेट. These are many minor plates तो बहुत सारा है, ठीक है. इसमें 1-2 याद रखो. अरेबियन प्लेट भी माइनर प्लेट है. So on what basis we have made this division? What is the basis on which we have made the division? Ridges and trenches. Both are considered to be the plate boundary. A ridge is a place where two plates are separated. For example, the Mid-Atlantic Ridge, North American plate, Eurasian plate, South American plate, African plate. This is considered to be the boundary. Trench. This is all trench. Trench is the part where the plates are getting destroyed. That is also considered to be the boundary. ठीक है? बताएंगे रुक जाए. ठीक है, सभी के लिए इतना क्लियर है. प्लेट्स कैसे हैं, मूवमेंट कैसे होगा, वो सब बात करेंगे. हाउ एग्जैक्टली इट मूव्स, व्हाट इज द रिजल्टेंट ऑफ दिस, है ना. तो अभी के लिए राइट अबाउट दिस. Introduction. Subheading Introduction. The term plate was coined by J.T. Wilson in 1965. J.T. Wilson in 1965. Stop. The theory of plate tectonics. The theory of plate tectonics was proposed by Morgan, Mackenzie and Parker. Morgan, Mackenzie and Parker in 1967. Next, subheading plate tectonics. Plate tectonics. First point. Plates are broad and rigid segments. Plates are broad and rigid segments of lithosphere which includes the rigid upper part of the upper mantle and crust Next point. The plates are in motion on an underlying asthenosphere which is in semi-solid semi-liquid state, which is in semi-solid semi-liquid state. Next point, plate tectonics. Plate tectonics is the study of deformation within plates and of the interaction of plates around their margins. Next point. Plates are nearly 100 kilometers thick and have high rigidity and are unable to deform except in response to very strong and prolonged force. Next point. There are 7 major plates. On the Earth's surface. What are they? Pacific, North American, South American, African, Eurasian, Indo-Australian, and Antarctican. Next point, there are many minor plates. Such as Nazca plate, Cocos plate, COCOS, Cocos. Nazca is NAZCA. Arabian plate, etc. नहीं, सब अलग है. छोटा साइज का माइनर प्लेट्स है. ऐसे बोलना मुश्किल है, बहुत सारा है. बीच में पीस तो बहुत सारा है. तो इसमें ये भी लिखना, एक और हेडिंग डाल के. Difference with respect to continental drift theory. continental drift theory and plate tectonics theory. So continental drift theory क्या बोलते हैं? Three layer structure, सियाल, सीमा, knife. Plate tectonics theory says this is Cl, this is Sima, below that asthenosphere. So this is lithosphere. Part of the lithosphere is plate. Okay, this entire unit is lithosphere. पूरा यूनिट को ही लिथोस्फीयर बोलते हैं. In this case, this single part is called as plate. Okay, this is the way it is imagined. Here, Cl is assumed to be freely floating over Sima. यहाँ पर बोला था, like if you remember the assumption, it said that the continental mass is floating freely over the oceanic crust. Right? In case of plate tectonics theory, it says that the plates offer high resistance. It offers high resistance while moving over the asthenosphere. It offers high resistance. ये बड़ा इंपॉर्टेंट है. अगर रेजिस्टेंस नहीं है तो कुछ ज़्यादा चेंज ही नहीं होता, वैसे था वैसे ही रहेगा. Now, the plate movements. How exactly the movements are happening? The important part. हाँ? मेजर दो ही है, बाकी सब जैसे पूरा समझ आएगा तब और क्लियरली बता सकते हैं. So this theory says that the plates are in continuous motion. In which direction? In all the possible direction. And that too, a plate is not necessarily moving in only one direction. Okay, let's say this is one plate, this is another plate, यहाँ पर एक और plate है, यहाँ पर एक और plate है, ऐसे imagine करो. इसका if this plate is moving in this direction here, it may also be moving in another direction in another end. In this direction in another end, and in this direction in this end, because the plates are so big in size, they cover thousands of kilometers and the movement is very, very slow. It is possible. ठीक है? The plates are moving in all the different possible direction. Because of this, we have three types of plate boundary. What is a plate boundary? The edges of the plates. Wherever there are plates, we can see there are three types of plate boundary. One type of plate boundary where two plates are moving towards each other. Another type of plate boundary where the plates are moving away from each other. This is called as divergent plate boundary. They are diverging away from each other. We are referring to the plate boundary, not the plate type. Okay, plate boundary is divergent plate boundary. Here, convergent plate boundary. In another case, the plates may be moving parallel to each other. Transform plate boundary. There are three types of plate boundaries possible. One is divergent, second one is convergent, third one is transform or parallel plate boundary. The plate boundaries are possible because not all the plates are moving in the same direction in same speed. All these plates are moving in different direction in different speeds, because of which we have different types of plate boundaries. Overall, there are three types of plate boundaries. Right about this. The plates are constantly in motion. The plates are constantly in motion, but with different speed and directions. But with different speed and directions. Full stop. This causes three types of plate boundaries. Three types of plate boundaries: divergent, convergent, and transform. Full stop. A plate boundary or plate margin, plate boundary or plate margin is a zone of motion, between two plates. Is a zone of motion between two plates. Let's talk about this one by one. First one, ocean divergence. Ocean divergence. What do you mean by ocean divergence? It's a divergent plate boundary at which on either side of the plate boundary we have oceanic plate. दोनों के साइड में oceanic plate ही है. So that is what is ocean divergent plate boundary. Okay, can you see this is a plate boundary? Okay, this is a plate boundary you can see here. This is one plate, this is another plate. At the plate margin, what we have? Ocean. This is oceanic plate margin, another plate is oceanic plate margin. I am just talking about the plate margin. It is not necessary that the entire plate has to be oceanic plate. ऐसे तो एक ही plate है. What is required here? Oceanic plate margin. Here there is the oceanic plate margin, here there is oceanic plate margin. In this case, both the plates are moving away from each other. This is what we call it as divergent plate boundary. First of all, why they are moving away from each other? So we'll discuss about the causes of plate motion in detail. पूरा detail में बात करेंगे. There are 5 major causes. So अभी के लिए बहुत briefly, why exactly the plates move? Because the magma from the inside continuously rises upwards in currents. In large scale currents, it moves inside. We call it as convection currents. Okay, it is called as convection current. It rises from the lower part of the magma, sometimes in the asthenosphere itself. It rises and it moves. in this manner. बहुत large scale में आता है magma, the magma which is getting generated. Wherever it is generating, wherever it is hitting the lithosphere, it is capable of breaking it, cracking it, and creating a plate boundary here. ठीक है? And as it moves, it will also push the plates apart. बहुत जगह में है. The entire earth is made up of such kind of convection currents. So that is, let's assume that that is the reason why the plates are moving. They are in continuous motion. We'll talk about this in detail. अभी के लिए इतना assume करो. The magma is continuously generated from the earth's interior and that is pushing the plates. In some places it is pushing them apart, in other places it is pushing them towards. हो सकता है, right? So in this case they are pushing both the plates apart. In the first place, why it is moving apart? Because the magma is rising here. That is the primary cause. The magma from the interior is rising here. And that rising magma has created a crack in the lithosphere. Earlier, this was a single oceanic plate. Earlier, this was a single oceanic plate. The magma started to rise and it cracked the entire lithosphere. इसको तोड़ के दो प्लेट बना दिया है. You may ask why it is happening here. It can happen anywhere. कहीं पे भी हो सकता है. The interior is working like that. The currents of magma can rise anywhere, even on the continent. Continents के नीचे भी rise हो सकता है. That creates continent-continent divergence. Here it has started to rise over oceanic crust. It has resulted in oceanic divergence. Okay, so now we are talking about this Delhi. Magma can start to rise here in Delhi also. Okay, so यहाँ पर दिल्ली से जो ऊपर का पार्ट है इसको अलग कर सकते हैं, नीचे का पार्ट को अलग कर सकते हैं. It is possible anywhere. It is possible. कभी भी हो सकता है. ठीक है? So that is what is convection currents. Convection currents are generated from the Earth's interior. We don't know exactly कब form होगा, कैसे form होगा. So it can happen anywhere. Here it started to happen. Here it started to rise, and this rising current cracked the entire lithosphere, which is made up of oceanic plate. It was earlier a single oceanic plate. It cracked the lithosphere. यहाँ पर एक पूरा crack बना दिया. And because of this it is separated. Lithosphere मतलब all the entire length of the plate is cracked. पूरा के पूरा crack हो गया. So इसके center से magma निकल के बाहर आता है. And now this has separated both the oceanic plates apart. दोनों को अलग अलग बना दिया. And wherever there is a crack, from this crack the magma comes out. What happens to this magma? It cools and solidifies and forms new oceanic crust on both the sides. And this newly formed oceanic crust will push the older one apart, causing the seafloor spreading. ठीक है? That is why seafloor spreading is happening. Wherever there is seafloor spreading, it is basically ocean divergent plate boundary. Ocean divergent plate boundary is where the magma is rising and it is cracking the lithosphere, and through this cracks the magma is continuously coming out, and this continuously coming out magma gets attached on both the sides of the oceanic crust and creates a new oceanic crust, and this will push the older ones apart. This continuously creates new oceanic crust. That is why ocean divergent or any type of divergent plate boundary is also called as constructive plate margin. Why? Because new plate is getting constructed here. New plate material is getting constructed here. It is getting attached to the same plate. It is expanding the plate. It is pushing both the sides apart continuously. The newer rocks are here, older rocks are here. Younger, older. Fine. At the center, we have a mid-oceanic ridge. Mid-oceanic ridge gradually develops along this. Okay, initially ऐसे एक plate था, crack हो गया. This rising magma started to melt both the sides. Okay, यहाँ पर थोड़ा सा thin हो गया. Gradually यहाँ पर material build up होगा. Over a long period of time, the material builds up here, and that is what we call it as a mid-oceanic ridge. We call it as mid-oceanic ridge. लिख रहे हो? Labeling is very important. So basically, wherever there are mid-oceanic ridge, that is the ocean-ocean divergent plate boundary. So wherever we have mid-oceanic ridge, on both the sides there is oceanic crust, and the oceanic crust is moving away from each other, away from the mid-oceanic ridge. The newly rising magma is resulting in the formation of new oceanic crust over there. That is why it is also called as constructive plate margin. It is called as constructive plate margin. So gradually as the new oceanic crust is created, a ridge is formed at this boundary, which is called as mid-oceanic ridge. Example, mid-Atlantic ridge. Mid-Atlantic ridge is a ocean-ocean divergent plate boundary between North American plate and Eurasian plate, South American plate and African plate. That is a ocean-ocean divergent plate boundary. Now, wherever the plate, a particular plate is in motion, what exactly is a plate? Plate is a very thick sequence of rocks extending up to 100 kilometers. It is made up of multiple layers of rocks. When a particular plate is in motion, okay, मान लो ऐसे इस डायरेक्शन में मूवमेंट हो रहा है, the entire plate is actually moving. When the plate is entirely it is moving, it results in the accumulation of energy in different parts of the plate, because it is made up of multiple different layers of rocks. Not all the layers of rocks will move together at a time. 100 kilometers का thickness है ना, पीछे से कोई धक्का दे रहा तो थोड़ा सा, some of the layers move slow, some of the layers move fast, because of which there is a friction between them, between the different layers. Sometimes some of the layer moves slowly, some of the layer moves fast, they get interlocked with each other, but the energy is continuously building up. After the energy reaches its maximum limit, it just snaps and releases all the energy at a time, causing earthquakes. That is how earthquakes are generated, due to the plate motion. Due to the plate motion, earthquakes are generated, and that is more active near to the ridges, where a new plate material is getting created and it is pushing the older ones. So we experience earthquakes along the mid-oceanic ridges due to the plate motion, where the plates are moving away from each other. There are high chances that the earthquakes can get generated here due to the build-up of energy. Now earthquakes are divided into three different types. Okay, तीन तरीके का earthquakes है, depending upon the depth at which the earthquake is happening, the depth at which the energy is being released from the surface. If the depth is between 0 to 70 kilometers, it is called as a shallow earthquake. Between 70 to 350 kilometers, it is called as intermediate earthquake. 350 to 700 kilometers of depth, it is called as deep-seated earthquake. The depth at which the energy is being released, okay, the depth at which the earthquake is actually happening, it will not happen at the surface, it happens below the surface. At what depth it is happening? Which type of earthquake is most dangerous? Shallow. सरफेस के बहुत पास में होगा, उसका एनर्जी ज्यादा रहता है, उसका इंटेंसिटी ज्यादा रहती है, it causes more vibration. If it is happening in the deeper part, by the time it reaches the surface, its energy decreases, intensity कम हो जाएगा. In case of ocean divergent plate boundary, what kind of earthquake we observe here? Shallow. Because the thickness of the oceanic crust is limited to 100 kilometer maximum, तो 0 to 70 में ही हो जाता है. They are all limited to the surface only. Then how exactly the intermediate and deep seated earthquakes happen? Okay, wait and see. Okay, next आएगा. So this is what is ocean divergent plate boundary. Is that clear? बस इसके ऊपर कोई डाउट है तो बताइए, दूसरी का बाद में देखते हैं. ओशन डाइवर्जेंस इज सेम एज सी फ्लो स्प्रेडिंग, जहां पर सी फ्लो स्प्रेडिंग हो रहा था. ठीक है. जैसे प्लेट को हम, जैसे हम थाली का प्लेट जैसे इमेजिन किया होता है ऐसे ही दिखता है, ऐसे नहीं है, ये बहुत बड़ा सा एरिया है। एंड एक साइड में इस तरफ खींचता है, दूसरी साइड में इस तरफ खींचता है, बीच में क्रैक हो जाता है, कभी कभी मैग्मा निकल के आ जाता है, ऐसे ही है। Okay, it is a very very large area and made up of multiple different layers of rocks and is moving very slowly in different directions. Okay, it is not one single layer, right? Multiple different layer, 100 kilometers of thickness है, so अलग अलग डायरेक्शन में होता है एंड इसके वजह से ये सारा इतना इंटरेक्शंस होता है। बहुत ज्यादा खींच के जा रहा है तो बीच में फिर सेपरेट होके मैग्मा निकल के आ जाएगा, हो सकता है। यस यस। And the plates which are presently here, 7 different plates, these are the present plates. The plate boundaries always change, they are not constant. ठीक है, plate tectonics पूरा होने दो, समझ आ जाएगा। So write about this. Ocean divergence. So यहां पर डाइवर्जेंट प्लेट बाउंड्री था ना, उसके ब्रैकेट में कंस्ट्रक्टिव मार्जिन लिख लेना, द ब्रैकेट कंस्ट्रक्टिव मार्जिन, मार्जिन और बाउंड्री refers to the same. A divergent plate boundary is called as constructive plate boundary because we have seen that a new plate material is getting constructed here due to the construction of new plate material here. Okay, first one, ocean divergence, first point. It is a type of plate boundary where two oceanic plate margins are moving apart in opposite directions. Next point. It is a zone of tension. Where lithosphere splits, comma, hot magma comes up through the cracks and solidifies leading to formation of new oceanic crust. Formation of new oceanic crust. Next point, the continuous built up of solid magma results in formation of mid oceanic ridges along the plate margin. Next point. In this plate boundary, shallow earthquakes with focus up to 70 kilometers is observed. With focus up to 70 kilometers is observed. It is ocean divergence. Okay, let's take a break. And after that, we'll talk about continent divergence. So we're discussing about divergent plate boundary. The best example of divergent plate boundary is Mid-Atlantic Ridge. So this is Mid-Atlantic Ridge, you can see. Here, both the parts of Mid-Atlantic Ridge is moving away from each other. The ocean floor is spreading away. At the same time, new oceanic floor is getting created. That actually means the size of this oceanic part of South American plate. Okay, this is the oceanic part of South American plate. This is the continental part of South American plate. दोनों merge हो गया. With time, the size of oceanic plate will increase. Right? ये तो बढ़ते जाएगा. It will start to grow. And this side again the same thing happens. The size of oceanic plate will start to increase in this side. They're continuously moving away from each other. Let's go back in time. Okay, reverse button dabao. What happens? They're moving towards each other. So now it is moving away. उसको reverse किया तो क्या होगा? They will move towards each other. So पूरा move होके gradually oceanic crust पूरा खत्म हो गया तो क्या होगा? There is continent divergence. That is how it began. The next one, continent divergence. It's not in every ocean. In this case, it is continent. Mid-Atlantic Ridge का ही है. See, what is the reason behind divergence? The upliftment of magma. Magma in large scale starts to rise all along the plate. This was one plate. यहाँ पर बीच में magma आने लगा था, and this cracked the plate and separated the plate into two different parts. This created ocean divergence. If this original plate was oceanic crust, if this origin plate was totally continental crust, still the rising magma can create two different parts, create continent divergence, right? It can create continent divergence, it can create ocean divergence. It all starts with the rising of magma. It can also start with ocean divergence only. ऐसे ज़रूरी नहीं कि हमेशा continent divergence से ही शुरू होना है. Originally it may be an oceanic plate. There may be a single oceanic plate. The magma started to rise and separated it into two different oceanic plates. It is possible. So let's understand this. You will get more clarity. Continent divergence. Continent divergence. So it's a type of plate boundary where two different continental plates, continental plate margins are moving away. It involves 3 steps. A continent-continent divergent plate boundary involves 3 steps. Number 1, intracontinental rifting. Intracontinental rifting. This is the first stage of any continent-continent divergence. It begins with a single continent getting cracked to form 2 continental margins. Earlier it was a single continental crust. Okay, earlier there was a single continental crust and it got cracked and formed 2 different parts of 2 different continental crust itself, 2 different continental plate itself. Why? Again the same reason, due to the rising of magma. Here also magma started to rise in large scale. There was a large convection current started to come up here, and that gradually melted the part of the continental crust. Okay, found its way in the upper parts and gradually broke the entire continental crust from here to here. Pura ke pura lithosphere ko crack kar diya. And it started to rise all along the plate. In its entire length, it started to rise. That separated the entire continental crust, continental plate into 2 different continental plate. This is what is we call as intracontinental rifting. It is called as intracontinental rifting. There was one single continent, it got separated into 2 parts. Why it happened? Because of rising magma. Rising magma. So how different it is from ocean divergence? There was a single oceanic plate. The rising magma separated into 2 different parts. How different it is? Here there is continental plate here, which is very thick. More than the thickness, it is lighter and more resistant actually. The continental rocks are more resistant, they are more buoyant. It will not let the magma to escape very easily. Oceanic crust was very thin, easily crack ho gaya, separate ho gaya. Continental crust will not happen that easily. It resulted in the formation of large number of faults. Itna smoothly separate nahi hoga. It cracks and causes a large number of series of faults, resulting in normal faults, reverse fault, transform fault, सारा faults मिल जाएगा आपको. ऊपर से एक पूरा ऐसे rift valley बन जाएगा. Because of the cracking of the entire continental crust. This is the side view, this is the top. This is the side view हम देख रहे हैं. So because of the cracking, we will find a valley which is called as rift valley. So why it happened? Because of the rising magma which cracked the entire lithosphere and it is trying to move it away. Why it is moving away? Because huge magma is coming up, large scale magma is coming up. Not every part of it will be able to escape through these cracks. A majority of these parts are actually moving in this direction. The magma which is rising is moving in this direction. It rises, cracks through the lithosphere, a part of it comes out, and majority of it is moving in this direction, trying to push both the sides apart from each other. The rising magma is pushing both the sides gradually apart. At the same time, it has cracked the lithosphere and some of it comes out. थोड़ा सा इधर उधर से बाहर निकल के आ जाएगा. But majorly you will see the formation of a huge rift valley. It is called as rift valley. Example, East African Rift Valley. The entire eastern part of Africa is cracking now. It is in the first stage. What is the first stage? Intracontinental rifting. Earlier this was a single continent. The rising magma has started to separate this. Okay, it has just started to separate this and you see a huge rift valley. How do we see a rift valley? This is what is a rift valley. A series of faults. Because the rocks are too resistant, it will not crack very smoothly, it will not get separated very smoothly. It results in the formation of faults here. Series of faults. Such series of fault is called as rift valley. It is very clearly visible even from the satellite. Okay, so this entire region is called as Rift Valley. This is what is East African Rift Valley. It has just started to separate. Separate होके then it will gradually move away. होगा volcanic eruptions तो होगा, but not in a very smooth manner. Along the mid-oceanic ridges, the magma comes out very smoothly because oceanic crust is very thin and both the sides are moving away very smoothly. Here it is a continental crust, very thick continental crust. It will not let the magma to escape very easily. So that's why in some of the regions the magma just builds up. Within the regions of lithosphere, first magma builds up. When the pressure builds up, then only it erupts out. Here and there it erupts out, but majority of the magma is pushing both the sides apart. It is trying to push both the sides apart. This is the first stage. Example is East African Rift Valley. After some time, when this stage continues for sufficient period of time, we have the second stage, which is called as interplate thinning. Interplate thinning. Why? You can see here the rising magma gradually starts to melt both the sides of the continental crust. उसको साइड से मेल्ट करते जाएगा because large scale magma is rising, right? It will start to melt both the sides of the continental crust. It will start to make the continental crust thin along the edges. After sufficient melting, this is how the continental crust the same continental crust has got melted along the edges. Edges में थोड़ा बहुत melt हो गया. The rising magma has melted this part, and the magma is still rising. And majority of them are moving in this direction. It is trying to push both the sides apart. This is continental, this is continental. अभी तो दोनों separate हो गए. That is why interplate. Earlier it was a single. It is called as intra. Here it is two different continents. Interplate. The magma is still coming out through this gap, and it is filling this gap. At the same time, it is pushing both the sides apart. However, you can see the gap which was there from the above has become widened. यहाँ पर तो बहुत it was a very thin crack. That is what we call it as the Rift Valley. Here it has widened. Gradually water fills here. From one end, इस side से या उस side से तो पानी enter करेगा. Ocean water तो it will enter. It will fill it here, resulting in the formation of a shallow sea. At the base of this shallow sea, there is a rift valley. The earlier rift valley is still there, through which the magma is coming out. Now the magma is coming out in much faster pace. Gap थोड़ा सा widen हो गया ना. So what happens to this magma? This magma starts to accumulate on both the sides of this continental crust, and is trying to push both the sides of the continental crust apart. Example, Red Sea. This is the part which is in the first stage. There was a single continental crust, continental plate. It has got separated. It is in the intraplate rifting. Intraplate rifting. First stage में East African Rift Valley. This is second stage. The gap has widened. Earlier even this was attached with Africa. a rift developed, a rift valley developed, and gradually it has started to move away. As it started to move away, the water filled this gap, resulting in the formation of Red Sea. इसके सेंटर में देखो यहाँ पर है रिफ्ट वैली, जो पुराना रिफ्ट वैली था ना वो अभी भी ऐसा ही है, जिसके थ्रू मैग्मा बाहर निकल के आ रहा है. Right? So gradually both the parts are moving away from each other. Earlier it was a single continent, started with intracontinental rifting. Second one is interplate thinning. Example Red Sea. And the third stage is formation of mid-oceanic ridge. Formation of mid-oceanic ridge is the third stage. ये कैसे आ गया? So what is happening here? The magma is continuously rising and getting attached to both the sides of the continental crust, right? So this magma is coming from below. It is the same kind of magma which was there earlier in the ocean divergence. वो भी नीचे से आ रहा था. That created which type of crust over there? Oceanic crust. This also creates oceanic crust only. The magma which is coming from below always creates oceanic crust. It never creates continental crust. Continental crust is a rocks which is made up of very light rocks. It cannot be created by the magma which is coming from below. जो mantle से आता है ना, it is slightly heavier in density. If it cools down, it forms only oceanic crust. It will not form continental crust. That is why continental crust will never get formed. जो पहले बन गया था वो वैसे ही रहेगा. ठीक है, वो कभी भी बनेगा नहीं. बनेगा कौन सा? Oceanic crust. Oceanic crust is something which is always formed because the magma which is rising continuously along the mid-oceanic ridge or along the continent-continent divergence, it results in the creation of new oceanic crust. Now this continuously rising magma will build up the crust here. इसको gradually यहाँ पर crust बनाते जाएगा. Which kind of crust? Oceanic crust. After sufficient movement of these, both the parts of the continental crust have moved sufficiently apart, and in between we have a newly formed oceanic crust. Due to the continuous expansion of this continental crust, the in-between gap is filled by the rising magma which creates oceanic crust. A new oceanic floor is created here. Entirely new oceanic floor is created here. The way new oceanic floor was created between South America and Africa. That is in the third stage. First stage example, East African Rift Valley. Second stage example, Red Sea. Third stage example, Mid-Atlantic Ridge. Even that was also in the first stage. During the rifting of Pangea, North-South rift develop हुआ था ना. The South America got separated from Africa by a rift, intracontinental rifting. Gradually the water filled up, formed a shallow sea. As it started to move away, a mid-oceanic ridge was formed in between, and that started to push both the sides apart. Gradually, due to the continuous accumulation of this oceanic crust, a new oceanic floor is created. And the place where the magma was earlier coming, it is still coming there. वहाँ से magma continuously निकल के आ ही रहे. So जिसके वजह से there is a oceanic ridge here. इस गैप से है ना, there is a small gap here, and through that the magma is still coming out. And this magma attaches on both the sides and creates new oceanic crust. Gradually it builds up, resulting in the formation of oceanic crust on both the sides. The magma is still coming out. As long as the magma comes out, it will push both the sides apart. Here we have oceanic crust which is totally newly formed, freshly formed. This was the earlier continental crust which is still moving away. For example, South America and Africa, they are still moving away from each other. Right? So now tell me, which type of earthquakes do you find here? Here also it is shallow only. Wherever there is a divergent plate boundary, you will find only shallow earthquakes near to the surface, because all the interactions are happening near to the surface only. ठीक है? So अभी बताइए, what is the reason behind the continental drift, which was not explained in the continental drift theory? What caused the continental drift? Basically, it is not the continents which were moving, it is the plate which was moving, and the plates were moving, and as it moved, it pushed the continents apart. Earlier, all the continents were merged together as a single continent. All of it started to rift apart with the first stage, intracontinental rifting. Gradually, as it started to get separated, there formed a sea, shallow sea. What was the sea? Tethys Sea. And it moved apart, and all the continents started to move in different directions. So it's not the actual continents which are moving, the entire oceanic floor itself is moving. The continents were just attached to the oceanic floor. In between the different continents, new oceanic floor was continuously getting created, and this oceanic floor was actually pushing the continents apart. Right? So this explains the movement of continents also. Right? So that is what is divergent plate boundary. So of course, if it is expanding like this, पूरा size बड़ा हो जाएगा, इसलिए compensate करने के लिए we have convergent plate boundary. We'll discuss that. वो separately बात करते हैं. Divergence clear है? So divergence can happen either between two oceanic plates or two different continental plates. Earlier it may be a single plate, a single oceanic plate can get separated into two different oceanic plates, or a single continental plate will get separated into two different continental plates. Gradually oceanic crust will be grown here, it will be developed in between. That is what is divergent plate boundary. Since a new oceanic crust is getting created, it is called as constructive plate boundary. Not more than 100 kilometers. The earthquakes happen near to the zone of divergence, and most of them are limited to the surface.
Can they happen in the second stage when the continents are
Still, the entire continental crust, we have maximum 100 kilometers of thickness. So most of the divergence, the action among themselves, they happen near to the surface. So you will see in constructive plate, the convergent plate margin, okay, why the intermediate and deep seated earthquakes happen. Come again. In which stage? Rifting. Second stage, thinning. The magma will not form. This is igneous rock only. Oceanic crust is igneous rock only. You're talking about the granitic rocks. The magma which comes from below, which comes from mantle, always results in the creation of basaltic rocks only. It will not cause the formation of granitic rocks. The basic nature of the magma itself is different. ठीक है, सो नीचे से जो आएगा उससे बसाल्टिक रॉक ही आएगा, उसका कॉम्पोजिशन ऐसे ही है. दैट इज वाई कॉन्टिनेंट्स विल नेवर गेट क्रिएटेड. Okay, it will never get created nor get destroyed also. Destroy भी नहीं होगा. So और clarity आएगा convergent plate boundary में. No, they are different. Aperogenic orogenic is the resultant of the internal forces. Okay, it is a movement. Aperogenic orogenic, they are the resultant of these internal forces. The internal forces के बारे में बात करते हैं. अफ्रीका का नहीं, ये बहुत नॉन वायलेंट टाइप ऑफ वोल्केनिक इरप्शन है. The magma which comes out through the continental crust, that results in slightly violent, but as the gap widens, the magma comes out smoothly. It will not result in violent eruption of magma. So there is no violent eruption of magma along Red Sea. Okay. I think in the sea floor spreading, so एक point में मैंने dictate किया था, age of the rocks decreases away from the ridge. That should be increases away from the ridge, right? एक बार check कर लो. Observation में तो आप लोग कोई नहीं बताया नहीं. The age of the rock increases away. ठीक है लिखो. So ये तीनों फिगर होना चाहिए. First one, intracontinental rifting, interplate thinning, and then formation of mid-oceanic ridge. The formation of divergent plate boundary. Formation of heading is continent-continent divergence. Formation of divergent plate boundary along continents involve three stages. Involve three stages. First, intracontinental rifting. Intracontinental rifting. First point. The upward movement of magma below a continental crust, below a continental crust causes the fragmentation of continent continents through creation of numerous cracks and faults. Numerous cracks and faults. Next point. Such a series of faults is called as rift valley. Is called as rift valley. Next point. Rising magma starts to come out through this rift. Example, East African Rift Valley. East African Rift Valley. Second, interplate thinning. Interplate thinning. First point, it involves partial melting of lithosphere. Partial melting of lithosphere and gradual thinning of continental crust. Gradual thinning of continental crust. Next point, Rift Valley starts to widen. Rift Valley starts to widen and may gradually get filled with ocean water. Ocean water resulting in the formation of a shallow sea. Formation of a shallow sea. Example, Red Sea. Third, formation of mid-oceanic ridge. Formation of mid-oceanic ridge. First point, the continuous spreading of continental plates away from each other and creation of new oceanic crust along the Rift Valley creation of new oceanic crust along the Rift Valley by the rising magma pulls the continental mass sufficiently apart. Next point, at this stage there will be a new oceanic basin. Along both the sides of mid-oceanic ridge. Example, Mid-Atlantic ridge. Example, Mid-Atlantic ridge. So basically Atlantic Ocean formed in the last 200 million years, 200 to 150 million years. That is why it is called as the youngest ocean, the Atlantic Ocean. पैसिफिक ओशन धीरे धीरे खत्म होते जा रहे हैं. यस, बट पूरा के पूरा तो खत्म नहीं होगा क्योंकि वहां पर भी एक रिड्ज है. वो अलग है. So next, convergent plate boundary, which is also called as destructive plate margin. Convergent plate boundary is also called as destructive plate margin. In that first one, ocean convergence. Ocean convergence. So what happens in a convergent plate boundary? Two different plates. ये पहले ही different था, ऐसा नहीं है कि अभी create हुआ है. Two different plates collide with each other. That is what is convergent plate boundary. Right? So in ocean convergence, on both the sides there is oceanic crust. Two different oceanic plates, they start to move towards each other. They start to converge towards each other. So that is what is convergent plate boundary. Whenever two oceanic plates converge towards each other, अगर दो प्लेट कन्वर्ज हुआ तो यूजुअली द लाइटर वन हैज मोर buoyancy, that is more floating capacity. Among these two, the lighter one will have more floating capacity and that will thrust the heavier one downwards. The lighter one will try to thrust the heavier one downwards. As they move towards each other, gradually let's assume that one of them is heavier. दोनों ओशनिक है, बट इसका मतलब ये नहीं है कि दोनों exactly similar density होता है. There will be some variation. So one among them is denser, one of them is lighter. Even the slightest थोड़ा सा variation है तो भी काफी है. So one of them is trying to push the other downwards. जो denser है वो नीचे जाना शुरू हो जाएगा. Gradually it will start to move down. ये जो denser है ना उसको नीचे push करेगा इसको. It will push it down because it has more buoyancy force. It will try to float. It will try to be near to the surface only. When both of them are converging, it will push the other one downwards like this. Okay, इसको ऐसे नीचे दबाता है. That process is called as subduction. When two oceanic crusts converge towards each other, one of the oceanic plate, which is slightly denser than the other, starts to undergo subduction. Okay, this was the original oceanic plate, oceanic margin, and assuming that this is heavier, it has started to undergo subduction, and being lighter, it is not undergoing subduction. ये तो ऊपर ही है. This is called as subduction, and the zone in which subduction is happening, it is called as subduction zone. Okay, this zone is called as subduction zone. And if you just observe the surface of the ocean, okay, surface of the ocean is very nearest to the ridges. Ridges के पास में तो बहुत पास में आ जाएगा वाटर के लेवल पे. तो देखो बाकी जगह में तो सेम ही है, ठीक है. यहाँ पर ऐसे वोल्केनिक माउंटेन आ गया, इसको छोड़ो. So otherwise, if you see along the subduction zone, it starts to become very, very deeper. Compared to any other part of the surface, it is the subduction zone where the surface becomes very, very deeper. That is called as trench. What is a trench? Trench is the surface part of this subduction zone, where two oceanic plates are converging, and one of them is subducting, below another one. देख रहे हो ना? ठीक है, लिखो मत। तो बाद में टाइम मत पूछना, जैसे जैसे बनाऊंगा वैसे ही इवन यू शुड ड्रॉ। This is oceanic plate. This is also oceanic plate. Both are moving towards each other. So one of the plate being denser, it has started to undergo subduction. So one of the plate is thrust downwards. And if you see the surface layers, compared to all the other surface layers, this part is the deepest part. Compared to any of the part of the oceanic bottom, this is the deepest part. This is what is trench. So what are the events? As two oceanic plates converge, one of the oceanic plate which is slightly denser will start to undergo subduction below another one, and the zone is called as subduction zone. And along the surface, it results in the creation of the deepest parts on the surface, which is called as trench. Now, what happens to this oceanic crust which is subducting? It is descending into the asthenosphere. This is lithosphere, this is lithosphere. It is descending into what? Asthenosphere. Asthenosphere is too hot. Temperature is high, because of which this oceanic crust gradually starts to melt. It gradually starts to melt. In the initial part, as it starts to undergo subduction, it is like it is being thrust into the deeper level. It is being pushed into the deeper level. The temperature is rising, pressure is rising. The rise in temperature and pressure causes the formation of metamorphic rocks. The rocks of this entire lithosphere will start to change its nature. We see a large number of metamorphic rocks in this region. It starts with a metamorphism. The rock starts to undergo metamorphism, and gradually it starts to melt completely. So the entire oceanic crust, which is made up of different types of rocks, in that some of them melt earlier. इसका melting point बहुत नीचे है. It will start to melt. So before the entire oceanic crust melts, these parts will melt. As it melts, it results in the generation of magma. This magma being lighter, it accumulates. It rises and accumulates on the other side of the oceanic crust. This melting is called as partial melting. This is partial melting क्योंकि complete melting तो यहाँ पर हो रहा है और नीचे होगा. Here some of the minerals are having lower melting point. It will melt faster. As it melts, it results in a generation of magma. The magma being lighter than the surrounding rock. ऐसे molten form में आ जाता है ना, it becomes very light. Being lighter than the surrounding rocks, it starts to rise. It starts to rise to the upper levels. यहाँ पर आके देखा तो यहाँ पर तो दूसरा oceanic crust है. It is the magma from this oceanic crust. Now it will start to accumulate on the other side of the oceanic crust. It will accumulate in the lithospheric layers of the other oceanic plate. But however, the magma is continuously getting generated. As the subduction happens, more magma is generated here. This magma continuously builds up, the pressure builds up, and finally it erupts out on the oceanic floor. This magma accumulates continuously, resulting in the formation of, इसको रिड्ज नहीं बोलते हम, volcano. It's a volcanic mountain. So what is a ridge? What is the difference between ridge and volcanic mountain? Ridge is there all along the length of the plate. It is just at one location. एक जगह में ऐसे आके accumulate हुआ है. It is just a single mountain. And it is not like a large scale magma is coming up. Only some part of the magma first it will accumulate, the pressure builds up, and then finally erupts out. Whenever the pressure builds up, it will erupt out. Many of the times you will see such kind of volcanoes in the oceanic floor. If this is the water level, let's say this is the ocean water level, oceanic floor में volcanic eruption होता है. Recently हुआ था last year, Tonga volcano, Pacific में. ठीक है, वो अलग है. That is due to the eruption of magma on the oceanic floor. But however, over a long period of time, this volcanic mountain builds up in height. After sufficient period of eruption, it comes above the water level, resulting in the formation of volcanic island. This volcanic mountain, which was earlier on the oceanic floor, it has started to grow continuously. Now it has raised above the water also. ऊपर से देखो तो बस काली ऐसे राउंड कलर दिखता है, राउंड शेप दिखता है, राइट? नीचे पूरा नीचे माउंटेन है. That is what is volcanic island. It's called as volcanic island. It is due to the continuous upliftment of magma along the convergent plate boundary. Here the subduction is happening. The subduction causes some of the material to melt and rise. Initially it accumulates and it erupts out and builds up the volcano, and finally it rises above the water level. This is what is volcanic island. It's called as volcanic island. कहाँ पर form हुआ? It is on the other side of the oceanic plate, which is not subducting. Basically this is subducting and generating a new volcanic island on the other oceanic plate. Along the entire length of the trench, the entire plate is subducting. It is not just happening in this location alone. The entire plate is subducting. Here also plate is subducting and rising. Here there is another volcanic island. Here there is a island. Here there is an island. You can see a series of volcanic islands here, and usually arranged in an arc shape. Series of volcanic islands usually arranged in an arc shape. It is called as island arc. It is called as island arc. Why arc shape? Because the trench is in arc shape. Okay, now why trench is in arc shape? Because the movement is not completely uniform. ऐसे straight line में नहीं जाएगा. कुछ जगह में आगे चले जाएगा, कुछ जगह में वॉइस नहीं है. Now, hurry. So in some place it goes faster, in some place it goes faster, in another place it's slower. Slower. Lower. So because of this the trench takes arc shape. जैसे ये आर्क शेप है, यहाँ का आइलैंड भी आर्क शेप में आ जाएगा. ठीक है. So because of this we have island arc. Island arc. Any examples? There are many such island arcs. Hawaii Island नहीं है. Can you see Japan? This Japan and this is trench. Pacific plate is subducting. Here the Pacific plate is subducting. Okay, this is the trench here. देखो, यहाँ पर subduct होके the magma is rising and building volcanic island. Over a long period of time, it has accumulated and it has resulted in the formation of island arc. Okay, यहाँ पर देखो, there is island arc. So this is again Pacific plate. Okay, this is Pacific plate. This is North American plate. North American plate में ये कौन सा स्टेट है? अलास्का. अलास्का का देखो ये एक आइलैंड आर्क ऐसे एक्सटेंड होता है. This is formed on the other side of the trench. Okay, these islands are Aleutian Islands. This trench is also Aleutian Trench. ठीक है? So here there is a trench. Can you see this? This is a trench and this is island arc. ये कौन सा है? Caribbean Islands. Like that there are many island arcs across the world. अंडमान भी हो सकता है. देखो अंडमान भी आइलैंड आर्क है. यहाँ पर भी एक ट्रेंच है. बढ़ता रहेगा. Island arcs will grow to become large group of islands. When large group of islands are formed, okay, मान लो यहाँ पर eruption हुआ है, यहाँ पर eruption हुआ है, ऐसे multiple group of islands बन गया. As they start to grow, it results in the formation of large group of islands. It is called as archipelago. It's called as archipelago. It started from volcanic mountain. Volcanic mountain became volcanic island. Series of volcanic islands became island arc. Large group of islands become archipelago. So now tell me, the subduction is happening. This is the lithosphere, 100 kilometers of thickness. But because of the subduction, the lithosphere is thrust into the deeper levels. The rocks in the lithosphere are still hard. It will go to much deeper level before it melts and become part of the mantle. Asthenosphere mantle में melt होने में बहुत ज़्यादा time है, मतलब बहुत नीचे जाके ही melt होगा. So before that there is a intense compression. The rocks are getting compressed. Energy builds up. The earthquake happens at shallow, intermediate as well as deep seated. It is along the trenches you will see shallow, intermediate and deep seated earthquakes. ठीक है? That is how intermediate and deep seated earthquakes are generated along the trenches. Whereas along the divergent plate boundary there is no subduction. All the activity is limited to the surface only. There is only shallow earthquakes. वो आएंगे और है कहानी. ठीक है? This is ocean convergent plate boundary. Now, see, earthquakes happens at every depth. It is possible that it can happen at every depth. We have shallow, intermediate and deep seated. But at certain depth we observe large number of earthquakes. एक depth में ना बहुत ज़्यादा earthquake होता है. Why? Because here there is a maximum compression. Near to the surface there is not much of compression. It is just beginning. You go to much deeper level, the rocks have started to melt in large scale, there is not much of compression. So at particular depth where there is a maximum compression, we find large number of earthquakes. Such zone is called as Benioff zone. उसको बोलते हैं Benioff zone. What is a Benioff zone? It is a zone in the subducting plate. Along the subduction zone, there is a one particular part where maximum number of earthquakes are observed. So that is what is Benioff zone. This is ocean convergent plate boundary. That is how the oceanic plate created in one end gets destroyed in another end, resulting in balance. So what happens if we bring continent into the picture? That we'll see. Any doubts here? Ocean convergence?
So what happens to that plate which is coming from that side? There is also contains increase in that plate. So that is not going anywhere. So
Which is not going anywhere.
the plate on the left side, which is not going to subdue, not thrusting downwards. There is also continuous movement from that.
So the doubt is if there is a ridge here, it is trying to push the plate in this side. but this is not going down. There is, let's say there is ridge on both the sides. Okay, let's just assume there is a ridge here and there is a ridge here. ऐसे तो नहीं है, मान लो ऐसे हो गया तो क्या होगा? Okay, the plate is pushing in this direction, the plate is pushing in this direction, this is subducting. What happens to this side? Either the ridge itself will move in this side or the trench will move in that side. नहीं नहीं, ये तो ऊपर ही रहेगा, सबडक्शन ही होगा. It may cause the trench itself to shift or the ridge itself to shift away. दोनों हो सकता है. नहीं, ट्रेंच के पास ridge नहीं आएगा. Anything else? कहाँ से? ये वॉल्केनिक आइलैंड्स है, इसीलिए तो जापान में इतना ज़्यादा वॉल्केनिक एरप्शन होता रहता है. रिज क्यों बनेगा? रिज बनने के लिए बहुत ज़्यादा मैग्मा चाहिए, लार्ज स्केल कंटिन्यूस मैग्मा चाहिए. ये तो बहुत कम मैग्मा है. इट इज फॉर्म्ड बाय द मेल्टिंग ऑफ लिथोस्फीयर इटसेल्फ. द रिज इज फॉर्म्ड बाय कन्वेक्शन currents, which is much more bigger in scale. We need more quantity of magma. It will not form a ridge here. Ridge तो surface के ऊपर ही होते हैं, that is generated by the, that is formed by the magma. ठीक है. So I know you will have many doubts. All of this will be cleared once we complete the plate tectonics theory. बहुत सारा, I think आधा तो थोड़ा बहुत अभी clear हो गया है. So थोड़ा सा भरोसा रखो, wait करो, हो जाएगा. So whatever the doubts we have, we'll take it up in the next class. Okay, let's finish the plate tectonics theory. I would suggest go back and read NCERT once. NCERT एक प्लेट टेक्टोनिक्स का जो पार्ट है वो एक बार पढ़ लेना, थोड़ा बहुत क्लैरिटी मिलेगा. बाकी सब हम नेक्स्ट क्लास में डिस्कस करते हैं. थैंक यू.